In the previous videos, I showed you how to integrate power functions and trigonometric functions, which were composite with linear functions. Both of these functions required their own specific rules. And in this video, I'm going to be showing you integrating exponential functions, which are composite with linear functions, and also requires its own special rule. As before, you can see that it has a linear component to it. And as before, the part that's most important in it is the coefficient of x, which is going to be placed in the denominator. Now, if you look at our first example, we see that the linear function is right here, and that the coefficient of x is going to be 5. And now as we integrate this, we'll just write 1 over 5 and rewrite the linear function once again, and we also add a c to it. Okay, so in the second example, if we have a look again at that linear function, we notice that the position of the x value is not in the first term, but in the second term, and that's mainly because it has a negative sign in front of it. And because we're interested in the coefficient of x, we'll say that the a value is -3. In rewriting this function, I'm also trying to show you that that constant 3 does not take place in the integration, so I can leave it outside the integrating symbol and just rewrite e7 minus 3x dx. As I now start to integrate, the 3 stays, and now I'll do the integration of the e to the 7 minus 3x. So as my formula indicates, I need to put 1 over minus 3. So I'll do that. So I will multiply this by 1 over minus 3. And then I just rewrite that same e to the 7 minus 3x as it is. And of course, just add the c. So in simplifying this, I will cancel the 3 and cancel the 3. And I'm left with a negative, followed by the exponent e7 minus 3 to the x plus c. Okay, let's do one more exponential integrals, and this time you notice that I have 2 exponential functions, one with a 2 in front of it and one with a 5 in front of it. In other words, it's actually an integral of a sum. So what we could do is we could separate these exponential functions into 2 separate integrals. The first one will be 2e to the x dx, and then we'll do a separate one for the other one, 5e to the 2x, and that's also dx. And once again, we can rewrite this because we can say any constant within the integral may be written in front of the integral sign. And so the 2 now can be in the front, ex dx, and also the 5 could be written at the front, and followed by that integral of e to the 2x dx. Now we can start the integration, so we'll leave the 2 out over here. And the integral of ex is just ex, just as differentiating ex gives us ex. We need to add the c to it as well, that is for this moment. And we go to the second part, the 5 stays as it is, and integrating e to x. So the 2x needs to be dealt in the same way as a linear function. And all the rules that we used beforehand, we use now. So the 2 is the a part coefficient of the x. So we will write it as 1 over 2. and then rewrite the e to the 2x again, and finish it off by writing up the constant c. And this rule could have also been applied to the first term where we had e to the x, because the coefficient of x is equal to 1. And then if we wrote 1 over 1, we'd just get 1. So it doesn't really matter. It's just ex for simplicity. In simplifying this whole equation, we just write 2 e to the ex. Now, there is this constant c in here, and there is another constant c in there. These are just constants, so we can just write them as 1. We do not need to repeat them twice. So I'm going to just write plus 5 over 2 e to the 2x. And in the end, I'll just finish it off with a plus c on its own. So I hope you have seen how I applied this rule above over here in integrating all of these three functions. The e to the x function was the simplest one, although that rule still applies over here, but you do not need to write it out. Well, in other words, that x can be treated as the linear function, and that 2x is treated as a linear function. And that's about it.